Alright, so this is for the Chapter 5 review for geometry. In number 1, it says classify the triangles by sides and angles. What the problem means when it asks you to classify the triangle by sides is how many sides are equal in your triangle. If there are no sides equal, scalene. If there are two sides equal, the triangle will be isosceles. And if there's three sides equal, the triangle would be equilateral. So in this first picture, there are markings to signify that all three sides of this triangle are equal. So therefore, this triangle is equilateral. And if I could spell correctly. In the second picture, 7, 9, and 12 are all the lengths of the sides. Clearly, none of these sides are equal, and that means this triangle is scalene. And in the third picture, these are marked to show you that these two sides are equal. And if you have two equal sides, that means your triangle is isosceles. When it says classify the triangle by angles, its meaning is the triangle acute, is it right, or is it obtuse? To be an acute triangle, you have to have all the angles acute. To be a right triangle, you need to have one right angle. To be an obtuse triangle, you need to have one obtuse angle. In the first picture, I know that all these angles here are less than 90 degrees. They're acute. In fact, since it's equilateral, I know that all these angles are 60, because all the angles have to be the same. So this is definitely an acute. 60 is clearly less than 90. In the second one, I'm not quite sure if this is a right angle or an obtuse angle. It doesn't look acute. So I'll check this by using a protractor or a compass. So I'm lining this up to 0. This is where 90 degrees would be. So if this were a right triangle, that's where the triangle would cut off. It's a little bit more than that, so this is going to be obtuse. This last one, this looks clearly more than 90. It's going to be obtuse. Excuse me. In number 2, I'm supposed to decide if the triangle is going to be scalene, isosceles, or equilateral. So I have to decide how many sides it has equal to each other. If it doesn't have any, then it's scalene. And if it has two equal sides, then it's isosceles. And if it has three equal sides, then it's equilateral. So I'm going to graph all these points. Here's Q. Here's R. Here's S. So before I decide if these are scalene, isosceles, equilateral, the way I decide is to find all their lengths. And the way to define all their lengths is to use the distance formula. So to find the distance between Q and R, Q is at -1, 3, R is at 3, 2. I just plug it into the distance formula. So 3 minus -1 squared plus 2 minus 3 squared. 3 minus -1 is 4 squared. 2 minus 3 is -1 squared. 4 squared is 16. -1 squared is 1. So QR has a length of the square root of 17. So let's pick another side and find that distance. Let's go ahead and try to find the distance between Q and S. Q is at -1, 3. S is at -2, -1. So again, distance formula. -2 minus -1 squared plus -1 minus 3 squared. This is -1 squared. This is -4 squared. This is 1, 16. So QS is also the square root of 17. I can rule out scalene. This triangle is definitely not scalene because there's two sides equal. Right now it's isosceles. We should check to see if it is actually equilateral, to see if all the sides are the same. So we need to find the distance on SR. S is at -2, -1. R is at 3, 2. So again, distance 3 minus -2 squared, 2 minus -1 squared. So this is 5 squared, this is 3 squared, this is 25 plus 9, and that's 34. So SR has a length of the square root of 34, meaning this triangle is isosceles and not equilateral, not scalene. In number 3, I'm supposed to find the measure of angle A. So I'm going to use the triangle angle sum theorem. I know all the angles in a triangle need to add up to 180. So I know that x plus 57 plus x plus 67 plus 70 has to equal 180 degrees. Okay, to solve this, I need to combine my like terms. X and x make 2x. 57, 67, and 70 make 194. And that should still equal 180 degrees. If I subtract 194 from both sides, we get 2x equals -14, and x is equal to -7. Don't let x being negative concern you. What would concern you is if your angle was actually a negative answer, and then you must have done something wrong. We need to find the measure of angle A. So let's plug that in for x plus 67. Instead of x, I'll write -7 plus 67. And so I can see that angle A is 60 degrees. On 4, I have to do the same thing, except there's a couple ways that I can do this problem. Keep in mind this is a right triangle, so that's 90 degrees right there. So one way I can do is x plus 49 plus x plus 59 plus the 90 should equal 180 degrees by the triangle angle sum theorem. All three angles add up to 180 degrees. So I can solve that and I would get the correct answer. Another way I could do this is that I could just go x plus 49 plus x plus 59 and now have that equal to 90 degrees. Because this right angle already used up 90 of that 180 degrees. So these two have to be complementary. These two have to add up to 90, to the other 90. X and x make 2x. 49 and 59 make 108 equals 90. Subtracting 108, I'll get 2x equals -18, and x is equal to -9. Angle A is the one up at the top, so if I substituted -9 plus the 49, I'll get that angle A is 40 degrees. In number 5, I'm going to need to use the exterior angle theorem, which says the two remote interior angles should add up to equal the opposite exterior angle. So in this case, the 7x minus 2 plus 11x minus 6, these two interior angles have to add up to equal this one on the outside. It has to add up to equal 100 degrees. 7x and 11x make 18x. -2 and -6 make -8 equals 100. Add 8 to both sides. 18x equals 108. Divide by 18. I get x is equal to 6. Now plugging in for angle A, that's 7 times 6 minus 2. That's 40 degrees for angle A. Number 6, I'm supposed to find the measure of each indicated angle. I need to find the measure of this angle. Again, I'm going to use the triangle angle sum theorem. If I can find this angle, use this triangle to find that one. So I'll add 55 and 25. That equals 80. And I'll go ahead and subtract that 80 from 180 degrees, because all triangles add up to 180 degrees. I find that that missing angle is 100 degrees. Well, I notice that these angles here are vertical angles, and vertical angles are always congruent. So this angle is also 100 degrees. And that gets me into the second triangle I want. I have two angles and that one missing, so 100 plus the 21 is 121. Go ahead and subtract that from 180. And I get the angle that I'm missing is 59 degrees. Okay, so number 7, still kind of have to work the same idea. You use all the information to get at this question mark. I notice that this 41 is out here, and it's vertical to this angle in here, and that's 41. So those are vertical angles. I have to make sure I don't get tripped up here. I don't want to write 70 there. That's not a 70, and these aren't vertical angles. They actually form a linear pair. And linear pairs are supplementary, meaning they add up to 180. So if I take 180 and subtract 70 from it, I get 110. That's that angle in here. If I'll take 110, add the 41, and subtract that amount from 180, and I'll get that my question mark is 29 degrees, that missing angle. And in number 8, I can use also again the exterior angle theorem. It says the two remote interior angles should add up to equal the exterior angle. So 115. So number 9 wants us to find the values of x and y. All right. So I think it's easier if we find the value of x first, since it forms a linear pair with this 110. So if I do linear pairs as supplementary, so if I do 180 minus the 110, that gives me 70 for x. If x equals 70 degrees. I'm going to redraw that triangle just because. Here's the 110 that they gave us. We found x was 70. Here's the right angle, and here's angle y. So to get angle y, I'm going to go ahead and take 90 plus the 70. That's 160, and subtract it from 180. So y is 20 degrees. At number 10, I have to do the same, solve for x and y. Notice how both these triangles are isosceles, meaning they have two equal sides. The isosceles triangle theorem says if you have two equal sides, you should have two equal angles. So here are my two equal sides. So in the bottom triangle, over here should be my two equal angles. The equal sides and the equal angles are always across from each other, like that. So if this is 55, this is also 55. That'll help me solve for x. 55 plus 55 is 110. Oof, what's wrong with my writing? Anyway, 180 minus the 110 is 70. So x is 70 degrees. Since that's 70, that means up here is also 70 because these are vertical angles. The top triangle is also isosceles, meaning that this angle right here is also y. So I have y plus 70 should equal 180. If I combine like terms, this is 2y plus 70 equals 180. If I subtract 70 from both sides, 2y is 110. Divide by 2, y is equal to that 55. Number 11. This is an isosceles triangle. You can tell because these two angles are equal. And on top of that, this problem is pretty dumb because they also put these lines there to show you that these sides are equal. And therefore, x is equal to 2x minus 6. If I solve this by subtracting 2x from both sides, that's negative x equals negative 6. Or x is equal to 6. Alright, in number 12, I have to state what theorem or postulate I would use to prove that the pair of triangles are congruent. And if they can't be proven congruent, I just write not possible. So the 5 things, the 5 theorems, or the 5 shortcuts, however you want to say it, that you can use on this is SSS, where you have 3 pairs of matching sides congruent. SAS, where you have 2 pairs of matching sides congruent, and a pair of angles in between the 2 sides. SA, which is 2 pairs of angles, matching angles, and the side in between. Angle, angle, side, which is 2 angles and a side that's not in between, and an HL. HL is only for right triangles. It's when you have a right triangle and the hypotenuse and the leg are congruent. So number 1, this is a right triangle. Sorry, right there. And side DB is equal to side DB because of the reflexive property. It's not HL though. So HL requires a right triangle and hypotenuse, which is this length, and one of the other sides. We don't have the hypotenuse. What we do have is these sides matching up, these angles matching up, and these sides matching up. And so if you look at one triangle, that's 2 sides and the angle is in between, and the other one, 2 sides and the angle is in between. So this is SAS. The next one, FH, again, is also equal to itself because of the reflexive property. So these are 2 side symbols there. This is an angle symbol. This angle is equal to this angle, and this angle is equal to that angle. So if you notice, if you cover up one of the triangles, you have 2 angles, and the side is in between. 2 angles, and the side is in between. So this is 2 angles, and the side is in between, or ASA. On 3, I have a pair of sides and a pair of angles, but I don't have anything else. I always need 3 things. I need a combination of 3 pairs of sides or angles, a combination to form these. I only have 2 pairs. So this is not possible. There's nothing else I can use to prove this. There's no reflexive property or vertical angles I can use to show that anything else is equal to. On 4, again, I have these angles here and these angles there, and I have this reflexive side. Okay, so I have 2 angles and a side in each triangle. 2 angles and a side, 2 angles and a side. It's either ASA or AAS. I just need to decide which one. Now the difference is ASA is 2 angles and the side should be in between. This side is not in between the 2 angles. So it's AAS. On 5, this side is reflexive, and so side, 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 side. 6. These angles are the same. This side is the same, but that's all I have. I don't have anything extra there. I don't have another side, I don't have another angle. So this is going to be not possible, because there's not enough information there. In 7, I have to actually do the proofs. I have to prove the following triangles congruent, labeling triangles, and naming the theorem. So I have to kind of do proof with statements and reasons and things like that. So my first statement is going to be anything that's given to me, DE, congruent to FE. And that's given to me from the markings. They tell me those are congruent. I know that this angle is equal to that angle. A lot of people will be tempted to call that angle E is equal to angle E, but that's not right. When you say angle E, I don't know which one you're talking about. So you need to be more clear. So I can say angle DEG and angle FEG. So DEG is this angle right here on the left. FEG is the angle on the right, and that's given to us that those are congruent. Both triangles have the line EG in it, so EG is going to be equal to EG. So that's reflexive property. Okay. And the triangles are congruent by side angle side. So triangle DEG is congruent to triangle FEG. And there's the proof. Number 8, kind of the same thing. So statements and reasons again. My first statement is going to be that angle J is equal to angle L. I can get away with using one letter for this angle, since there's no confusion. When I say angle J, everybody and their mom knows that that's angle J. I say angle L, everybody knows that's angle L. That's given. It's also given that this side is equal to that side. Side JH is congruent to side LM. So I need to find some other thing. I always need 3 things. I only have 2. There's no reflexive side, a side that overlaps them, but there are these angles here. Those angles are congruent. Now again, a lot of people are tempted to call those angle K. It's not clear enough. So if I need to say the angle on the left, I would say JKH. And the angle on the right, I'd go with LKM. And those aren't given to us. They weren't in the picture. I know those are equal because they are vertical angles. So I can go with the definition of vertical angles, or just vertical angles is good enough. Vertical angles are always congruent, no matter what the case. And then now I have 3 things. My triangles are congruent. JKH, LKN. And this is angle, this is an angle, that's an angle, that's a side. This is angle, angle, side. And number 9, again, I have to do a proof, statements with reasons. NR is congruent to PQ. That's given to me. NP is congruent to QR. That's given to me. And this should be equal to itself because it's shared between both lines, both triangles. So RP is congruent to RP because of the reflexive property. And lastly, the triangles are congruent because I have 3 things now. RPN, PRQ, and these are all sides. So side, side, side. So 13 and 14, I need to list the pairs of congruent sides and congruent angles. I can look at the picture and try to get this on there, or I can look at the congruency statement. I'm going to look at the statement. The statement's written very precisely. It tells me that angle W matches up with angle J. So I'll just write that. Angle W should be the same as angle J because they're both the first letters in the statement. So if I follow that, angle X should be equal to angle K. These are the second letters. Angle Y should be equal to angle L. And angle Z should be equal to angle M. For sides, we use two letters for sides, so like WX, since those are the first two letters, that should be equal to JK, since those are the first two letters. XY should be congruent to KL. YZ should be congruent to LM, and ZW, should be congruent to MJ. Okay, so in 17 to 20, I need to know, or I need to say what other information, what's something extra I need to know to prove these triangles congruent by these things. So I need to prove that this needs to be by ASA. So to use ASA, I need two angles on the side, two pairs of angles on the side. I already have one pair, and I also have this pair. LY is congruent to LY by reflexive. So I have one pair of angles and a pair of sides. I'm missing another pair of angles. I can't just pick whatever angles I want. I really need them to form ASA. So I need the angles to be here and here. That will get me angle side angle. So I need angle CYL to be congruent to angle ALY. Again, same thing for AAS. I have a pair of angles here and this side. So basically I can have any other angles, it doesn't matter. I can have angles here and here, and that will give me angle side. I could have used angles here, and that would have done the same, or angles here and here, that would have done the same, angles there and there, it would have done the same. It doesn't matter as long as you name angles. LKM is the one I chose. JKM for that. For 19, I need to use HL. So HL only works with right triangles. That's the first requirement. These are both right triangles. And needs a hypotenuse and a leg. I have this side. This side are legs. They form the right angle. So I need the hypotenuse is also equal to each other. I need this side to be equal to that side. I need HG to be equal to HJ in order to use HL here. And again, on 20, to use HL, I need right triangles. They have hypotenuses and legs there. I need right triangles. So I need angle C and angle F to both be equal to 90 degrees. I need them both to be right triangles. In 21, I need to just give out the reasons for this proof. They have all these givens. So given that line AB is parallel to line DC and BD, just using that in the picture, it's supposed to prove that BC is equal to DA. So first statement is AB is parallel to DC. Well, that's easy, that's given to us. Because that is parallel, okay, whenever they use parallel lines in a proof, what they're setting you up to use is alternate interior angles. See how like that forms a Z, where this angle is congruent to this angle, or BAC is congruent to DCA. So some teachers let you write the alternate interior angle theorem. I don't like that because I can't remember what that says. But if lines are parallel, then alternate interior angles are congruent. That's what I have my students write. So they actually remember, oh, I only use this when lines are parallel and stuff like that. So they don't use it inappropriately when lines aren't parallel. So yes, I make my students write that. Number 3, angle B is equal to angle D. That's in the given statements. So that's given. AC is equal to AC. Well, that's reflexive. So now I have two angles and a side in each triangle. That means the triangles are equal by angle, side, because the side is not in between the two angles. And the last statement is that BC is equal to DA. Okay, we have equal triangles. And if I have equal triangles, these parts should also be equal. And so that's a special thing in geometry called corresponding parts of congruent triangles are congruent, or CPCTC. Basically meaning if your triangles are equal, all the matching parts should be equal. Alright, and 22. Supposed to graph this rectangle with these given vertices. Okay, so pretend this is my origin, or sorry, my Cartesian plane. N is at the origin, so N is at 0, 0. L is at 4a, 0, so let's pretend L is over here, and that's 4a, comma 0. M is at 4a, 4b, that's somewhere up here. 4a and 4b. In order for this to be a rectangle, their last point needs to be over here at k, and that should be at 0 for the x value, and up the same amount as m, so 4b, for the y value. So that's the coordinates of k, 0, comma, 4b. And then they asked if I could find the middle on each end. The exact middle between n, which starts at 0, 0, and L, which is at 4a, comma 0. Like right in the middle, wouldn't that just be 2a, comma 0? I could use the definition, or the midpoint formula, by taking, since L is at 0, 0, and, sorry, that's where n is, and L is at 4a, comma 0. I can take the x values and add them up and divide by 2, and the y values and add them up and divide by 2. But I think it makes more sense to use just common sense. So you see I can still get 2a, comma 0. Right in the middle of LM, middle of here, if I'm along that line, my x value isn't going to change. So the midpoint, the x value of the midpoint, it's still 4a. But between 0 and 4b should be 2b. Again, I can take these, add them up, divide by 2, add these up, divide by 2. I'll get the same 4a, 2b. The midpoint between m and k is the middle between here. Between 0 and 4a is 2a. But the middle between 4b and 4b is still 4b. Between k and n, the middle between 0 and 0 is still 0. Middle between 0 and 4b is 2b.